My name is Sarah Hathiramani, and I work on one of the counter-abuse technology product teams at Google. As you heard Jen Fitzpatrick talk about earlier, right here at I/O, we keep more people safe online than anyone else in the world, with products that are secure by default, are private by design, and put you in control. Today, I'm excited to share a bit more about how our teams do this work at scale. I'll spend some time talking about our team's recent work to keep people safe, in some cases by introducing new technologies across all our platforms. You might be asking, what do counter-abuse teams at Google do? We develop detection systems that identify and respond to both existing and novel forms of abuse. We also collaborate with product teams to build safety into our products from their inception to help prevent abuse before it takes place. We build infrastructure that helps us protect our users at internet scale. And we provide transparency into our work, including transparency reports about our user protection efforts. Many of you are probably already familiar with forms of online abuse like scams, fraud, malware, and phishing. These are some, but not all of the types of abuse we spend time identifying and then building scaled systems to detect and prevent. But abuse can appear in many different ways. One way to think about it is to consider that any time an individual is exploiting a product feature to harm another user or the underlying system, that's abuse of our products, features, or systems. Before we can even start to work on technology to stop abuse, we have to consider what forms abuse can take and how people might seek to misuse or exploit our systems. This is especially challenging because Google is constantly working on new products, and the technology industry as a whole is always evolving. As we develop new products and we think about how they can be helpful to people, we also think about how these new technologies might be exploited or misused. This means that we have to work hard to ensure that our counter-abuse capabilities meet the needs of an ever-evolving abuse landscape. One example of such a technology is end-to-end encryption, as well as other privacy-preserving technologies that are becoming more popular as a way to protect individuals' data. We are committed to building safe systems that maintain these privacy protections, prevent abuse, and ensure the integrity of our users' devices. The privacy protection offered by end-to-end encryption is one important precursor to building safe systems. Being able to verify device and data integrity is another. For example, if we can verify that an Android device is running unaltered operating system software and similarly unaltered apps, we can draw reasonable conclusions about the integrity of the device. This allows us to more holistically understand the extent to which we trust the device and deliver safer product experiences accordingly. Our goal is to build systems and devices that have defense in depth. That is, multiple layers of defense built into them. Things like privacy protections and verifiable device and data integrity deliver multiple layers of defense against abuse. Another example of our approach to defense in depth is the Pixel 6 and Pixel 6 Pro. When we introduced these devices, we also introduced binary transparency for Pixel factory images. Binary transparency is a core technology that counter-abuse systems can be built upon. It increases the opportunity for third-party organizations and individuals to verify the integrity and the provenance of a binary. Binary transparency can trace its origins to certificate transparency. Certificate transparency, which some of you will be familiar with from TLS certificates on the web, provides the ability to verify correct issuance of certificates. While a signed certificate by itself includes one layer of verifiable integrity via its digital signature, certificate transparency adds broader public verifiability. By putting a signed hash of the certificate in an append-only, publicly visible transparency log when the certificate is issued, it's quickly verifiable both which organization issued a certificate and when. This capability provides the opportunity for everyone to be on the lookout for misissued certificates so they can be detected quickly. Signatures alone don't allow for such rapid detection. Certificate transparency, or CT, has been so effective and successful that no modern browser accepts TLS certificates that aren't in a CT log. The idea behind binary transparency is similar to CT, except that we apply these same transparency principles to other binaries rather than just certificates. Instead of putting hashes of certificates into a transparency log, with binary transparency, we put hashes of a binary, in this case, the factory system images for Pixel 6. Last October, we released additional detail along with developer tools to allow the technically inclined to verify that the system images of the OS installed on Pixel 6 are in the log. With the ability to verify that the system images are in the log, people are able to ensure that their phone has the same bits that Google released and that the bits haven't been altered at some point along the way. If you search for Google Binary Transparency, you can find both the introduction page as well as the page specific to Pixel Factory images. If you want to learn more about the core concepts and infrastructure behind this system, you can also check out binary.transparency.dev. In addition to launching binary transparency for Pixel Factory images last October, we also launched and are discussing here, for the first time, a second implementation of binary transparency within Pixel 6. This second binary transparency system enables a new approach to help prevent scams and phishing. Starting last summer, Messages by Google has been able to protect messages with end-to-end encryption when sent via Rich Communication Services, or RCS. When messages are end-to-end encrypted, the servers handling the transmission of the messages can't check the actual messages. To protect our users from scams and phishing, we integrated on-device protections for this form of abuse. If users have these protections enabled, the protections apply to the user's messages once they're received on the device, regardless of whether the messages are encrypted. These on-device protections work on users' devices without sharing information, like the message content, back to Google, or breaking the end-to-end encryption of the messages. This is a privacy-preserving way of providing the best, consistent level of protection for our users and their messages. To further preserve privacy, we believe that adding verifiability to deployed on-device anti-abuse technologies is an important first step in this space. Adding more verifiability to on-device counter-abuse systems provides more assurance about their integrity. For example, if an anti-abuse model fails to verify on device, perhaps due to a network issue, it won't be used and the system will wait until it can receive a verifiable one. This approach ensures that on-device detection is based on sound data that is bit for bit what the back-end system sent. To that end, we added binary transparency to the infrastructure that delivers abuse prevention updates to devices. This means that we can verify both the integrity and the provenance of the update before it's applied. We're pleased with the privacy properties of this innovation and are continuing our research in this realm. In the future, we hope that others in the industry will operate binary transparency logs as well, just like how certificate transparency works today. We also expect some organizations, commercial and research alike, to operate so-called witnesses, which are systems that keep an eye on the correct operation of the logs and verify their consistency. As the evolution of certificate transparency taught us, transparency ecosystems are successful only if there are multiple logs, which means no single point of failure, and multiple witnesses to ensure rapid detection of a log becoming unavailable or otherwise misbehaving, for example, in the event of a connectivity problem. Thank you for taking the time to learn more about our commitment to keeping people safe in an ever-changing environment. As the industry evolves and new technologies emerge, we remain committed to developing and inventing privacy-preserving technologies that prevent abuse. We look forward to ongoing conversation and innovation in this area, and we thank you for being on this journey with us. Thank you.